Hello guys, so I'm back with another video. In previous video we looked at how to get a side and unknown side of a right angle triangle using a side and an angle other than 90 degrees. So in this video we want to look at how to get an angle inside that triangle using two sides of that triangle. Okay, so let's get to it. Okay, so to find an angle using trig ratio, we use the inverse function. I don't want to leave you behind and funa ukukushiya up because ngoku ndithetha nge-trig ratio ne-inverse function. Kwenzakala ntoni? Remember, if you have a triangle like this one with an angle theta, you are given theta and this side is x and this side is y, right? So if you take sine, for instance, and you substitute the angle theta, sine is going to give you the opposite of theta over the hypotenuse. So sine, if you substitute an angle in sine, is going to work out a ratio, right? So the normal trig functions, what they do is they relate an angle to a ratio, but an inverse relates a ratio to an angle. So it works in reverse or in opposite direction. So let me show you how it actually works. Let me show you how it works. Okay, so an inverse, you would be looking for theta, right? So you would then say, okay, theta is an angle, so theta is going to equals to sine inverse of x over y, right? Because now you have to substitute a ratio so that you get what? An angle. Unlike in the case before this one where we were substituting theta so that we get a trig ratio, right? This is important for us to know because you will see me writing sine inverse and you need to understand why I'm writing sine inverse or cos inverse. Okay, let's move. Just want to take this off. Okay, so let's move. So this is a simple generalization. So if you are looking at this is beta. Apologies about that one. Let me put a black color there. So this is beta, not theta. Okay. So what I'm saying here is if maybe I have the ratio AB over AC, right? Which is and I'm looking for beta. What would you do? Then I would then say, okay, from beta, from this angle, because we need to work from the angle. From this angle, AB is the opposite, right? Is the opposite. And then AC is obviously the hypotenuse, right? So here I have sine. I can clearly see that if I then take sine of beta, I will be able to get AB over AC. But now I'm not looking for sine beta, I'm looking for beta. Then I will be able to say, okay, if I'm looking for beta, then I must substitute the ratio so that I am able to get the angle beta, right? Okay, so let's move. So here is an example. Here is an example. I always believe that in maths makes a lot of sense. An example will always bring a lot of clarity. Okay, so again here they want us an angle. So I'm going to go mark the angle. Let me mark it red. So this is the angle Since they are looking for that angle, then I'm going to say, okay, what do I have in relation to that angle? I have the opposite. And the opposite is 3. And then I have there the hypotenuse. And the hypotenuse is 6. Right? So, if you are to look at the information that you have, you can see that this is related to the sine function, right? So you write sine of beta would give me 3 over 6, right? But I am looking for beta, so beta would be equal to sine inverse. Then I would substitute the ratio, and then I would get that beta is 30 degrees, right? Let's move. Here's another example. Again, I'm going to check from the angle that they want. I have information here. So I'm going to say, how is the information that is given related to the angle that they want? So I'll say from this angle, I have the opposite, which is 3. Then I have the adjacent, which is 5. Adjacent and the opposite, that is tan, if you are looking at it. So I'm then going to say, okay, tan of theta. So if you were to take tan and substitute theta, you are going to get the opposite of theta, which is 3 over the adjacent, which is 5, which means that then tan theta is tan inverse, because I have to substitute the ratio, tan inverse over 5. And then let me quickly calculate that. Shift tan of 3 over 5, close bracket, then you are going to get 30 degrees. Theta equals to 30.996 degrees. Okay, so let's move. Here they are looking for beta, so this angle is beta. Apologies. Okay, so I'm going again to work from the angle and say, okay, I have the hypotenuse, I have the adjacent here. So this is related to cos. Then I'm going to say, okay, cos of beta is root 3, which is the adjacent over the hypotenuse, which means beta is cos inverse, because I want to substitute the ratio so that I can get what? The angle. Then I would get that beta is equals to 30 degrees. Okay? See if I have another example here. Okay, so we have exhausted the examples, so these are the notes. It is important to note that in each of the cases covered in this slide, 2 sides were given, and thus Pythagoras theorem could be used to get remaining side. Let me put green there, so that you have freedom to which inverse to use. Let me go up and clarify that. I'm going to clarify that statement. Sithi nesi statement sithi uba unokwazi ukusebenzisa uPythagoras apha, and then ube so une freedom yokusebenzisa nayiphi na i-trig function of uyisebenzisa. Okay, so we know that ngoPythagoras 2 squared, which is hypotenuse squared, is equals to square root 3 squared plus b c squared by Pythagoras. Right? Which means then I would then get 4 minus 3 equals to bc squared, 1 equals to BC squared, take square root of both sides. You would then get that BC is 1. So you put in 1 there. Now, since you have calculated that side, now you can use any trig function you want to use. So I'm going to then use, maybe let's say, let me take tan. Tan of beta, for instance, will be equals to opposite 1 over adjacent square root 3, which means that beta is equals to tan inverse of tan inverse of 1 over root 3, and you are going to get exactly 30 degrees. Going to get exactly 30 degrees. Okay, so that's basically what I'm saying in the first point there. You can take this out so that you can see exactly what is happening. Okay, so that's what I'm saying there. I'm saying that you could have used Pythagoras if you wanted to, so that you get freedom as to which trig ratio you want to use. But I mean, this is going to take a lot of your time when you are busy trying to calculate using Pythagoras theorem, when you could just use the information that was given, and then you relate it to a trig ratio, then you solve for the angle. Okay, but it's always good to make sure that you get the max. The most important thing is to get the max. If you see that it's difficult to make connections, then you can just use Pythagoras theorem and just use whichever trig ratio you want to use. Okay, so let's move. I personally focused on what was given to save time. Yes, I focused on what was given to save time. Like I said, that it will save you a lot of time to just connect the given pieces of information. This slide focuses on strictly on basics, and higher order questions will be covered under combined revision, where we will be consolidating our trigonometry. So yeah, of course, I'm only going to look at the higher order questions when we are dealing with the revision. It's very important that we make sure that we ground ourselves and we get the basics, because without the basics, we're only going to get frustrated when we have to then deal with higher order questions. Thank you. So please don't forget to like the video, subscribe if you haven't subscribed, comment. I am always open to hearing your opinions, what you think should be improved and all that. We can only grow together. So guys, please also share the link to the channel so that we can grow the family. Thank you guys.